slides?
Yeah, we see them.
Okay, very good. So a short introduction. So my name is Veli-Pekka Salo. I work for the Wapice Ltd as a team leader and OPC UA expert in the IoT and communication technologies segment. Just a few words to start with. Today I will tell a use case example also from Finland. So this concerns Helen, but before that, a short introduction to Wapice. So we are a Finnish software house specialized especially to digitalization in industrial companies. I invite everyone to visit our web pages and read more from there. We have a large set of services. We are strong into analytics and AI and also into cloud and IoT technologies. But I quite recently checked that we became the OPC Foundation members already 2001. So I think we have done almost exactly 20 years of OPC and OPC UA solutions. And yeah. So let's go more into the Helen. So Helen is one of the largest energy companies in Finland and founded already 1909 and owned by the city of Helsinki. And currently they have over 500,000 customers throughout in the Finland. And basically in the capital area, the Helsinki district heating network covers more than 90% of the buildings in Helsinki, and yeah, very ambitious targets. So they aim for being a carbon neutral by 2035. And if we look at a little bit the portfolio, what kind of energy sources they have, so they have let's say more traditional energy sources. For example, the Salmisaari heating plant, Hanasaari heating plant. So, for example, Salmisaari is very efficient combined heat and power generation plant. So they produce electricity and heat in single process, and then the energy is supplemented from other sources, like there's water power and also more and more renewables like hydropower, heat pump plants and solar power plants. And if we look how Helen is competing globally, so they are very highly energy efficient, and they have even been awarded the award for the world's best city energy because of this highly energy efficient production style. So nowadays the trend is from the bigger production units to the smaller decentralized production units. So when we are moving from the centralized bigger plants to a more like a decentralized plants like solar plants or heat pumps and similar. So then this brings challenges for managing the grid operations. So information becomes scattered, and then also more and more transparency and predictability is needed for controlling the energy flows. And also people require more personalized services and fast reactivity also. So this all requires digitalization and automation for the producing of the energy. On the same time, there are some challenges. So traditionally, the information system used to be owned and administered by several different suppliers, and there was vendor-specific systems how the energy was collected from the different sources, and this is of course expensive and error-prone. to connect everything using this kind of systems. So already 2014, we started cooperation with Helen to investigate how to replace these vendor-specific systems with the OPC UA. And there was a need for simple and scalable architecture that has a long-term support and a clear future roadmap. And yes, so OPC UA was selected. So it's vendor independent, scalable, and it has inbuilt security. And already 2014, it was seen that this protocol will have a roadmap that is reliable and can be trusted. And now this brings a freedom of architecture in a point that the SCADA systems and information systems in the production units, those can be customized quite freely. And it doesn't matter anymore who is the vendor, as long as they talk the OPC UA towards the other systems. And what we achieve with this is that we get a clear responsibilities inside the Helen between different operators and in systems. And this kind of very simple architecture, so it's easier to scale up and integrate with third-party systems, and also maintenance and problem solving becomes much easier. When we started thinking about the solution, we already back then we had one of our products, IoT Ticket, which is basically a complete Internet of Things solution for storing data and working with the data. So you have the connectivity, you have the dashboards, you have events, and also the data storage systems. So we took this solution as a backbone into the system. So IoT Ticket basically forms the data storage system, and then also the visualization for the user. And basically we implemented then the OPC UA modules for that. So Power Factory communication is done using the OPC UA Client, and then the data is aggregated to the system and then provided further to the portfolio. Let's say portfolio computation and managed by the OPC UA server. And in some places, it's still mandatory to do wrapping from the OPC DA to OPC UA protocol, and also vice versa from OPC UA to OPC DA. Let's see if I can make this smaller. If we look at the architecture shortly, so basically the core system we can see, we have the IoT Ticket as a core. We have a process database for the let's say process data, and then for the user data and configuration we have a metadatabase. And then towards the Power Factories we have the OPC UA security. If you look at the few simple use cases, so of course for those who are not familiar with the OPC UA, so the precondition for the communication is that we have a certificate handshaking between the OPC UA source and OPC UA client. So that must be done first. Basically, the certificate is just it's a public-private key pair, which is then used for trust, checking the trust relation and signature of the messages and so on. And once this trust relationship is established, then it's actually plug and play to connect the items from the Power Factory. So basically, administrator then configures the endpoint URL and node IDs he wants to read from the factory. A system connects into the factory and reads data into the process database. And then actually comes the big beef that once we have all the individual plants are basically aggregated to the IoT ticket system, then the OPC UA server can very simply provide the data further. So then we have the portfolio computation and basically the data for the stakeholders, so the KPI information, portfolio management, and so on. Also the analysis for the data. So that is very easily can read the whole set of data from the OPC UA server, and basically this system then takes care of aggregating this, and also connecting to the third-party systems becomes a lot easier. Few examples of where the OPC UA, especially the data and services, is very useful. So in OPC UA we have the quality and status information, so that first of all gives us immediate feedback about the source system. Is the data valid? Can we trust it? Then we have the source and server timestamps, so we can constantly monitor what kind of delays we have, for example, in the system, and we can track the problems. And OPC UA also natively supports events. So, for example, if I have new sites added into the system, then it or the measurement points are removed from the system, then the system is able to use these OPC UA events to notify the external parties that, okay, now the system changed and you need to do something, and then update the address space, for example, automatically. And second is, of course, OPC UA very well supports the performance monitoring. So of course, in system critical place, we have a 24/7 monitoring of the system and network performance. We monitor, for example, data storage performance, application performance, SMS, and then we have a SMS and email-based alarms, for example. And OPC UA, it has basically high availability by the design. So we have several layers of fault tolerance. So we have redundancy in the OPC UA protocol level. So for example, let's say the OPC UA client system is redundant. So we have redundant OPC UA clients, and then also the source servers, there can be redundancy. So in case, for example, some of the OPC UA source servers is not available, then we are able to automatically connect the redundant server. Then we have let's say, application redundancy. In case we, for example, want to do software updates, or so we can turn on and off some components, and it doesn't basically harm the system at all. Then we have database redundancy and network redundancy also. So basically the system is designed so that there's no single point of failure anywhere, and OPC UA is very suitable for this. It's basically one of the building blocks that helps us to achieve this target. I think I'm a little bit early, but it doesn't harm. We have some time for the questions. Then with the OPC UA, we really achieved in this case a very simple and future-proof architecture. And in this case, the OPC UA and our product, the IoT ticket platform, they supported each other in best ways. And because of the OPC UA, we have very streamlined processes, easy architecture, clear responsibilities, and that all leads into the cost savings. And of course, then allows Helen to focus more on the core business and value creation. Okay, thank you everyone. Thanks for the opportunity to speak here.